In today's video, we'll be looking into a scope panel feature inside of Affinity, which might seem a bit daunting at first. However, we'll try to explain the concept behind the scopes panel in a much more simpler way inside of Affinity in this video. So if you haven't subscribed to our channel yet, please hit the subscribe button for more helpful tips and tricks related to Affinity. Now with that said, let's start with the video. So in order to access the scope panel, first of all, navigate to the top and select the Windows option. Inside of the Windows option, hover over the pixel option, and inside of the pixel option, select scope. After selecting scope, you'll be able to see the scopes panel right here. And inside of the scopes panel, first of all, there are different integer numbers that you can see here, which we can use in order to observe different color tones and values inside of any image to make a better decision for the adjustments that we will apply in the future to that image. So the first category that we have is the intensity waveform category that you can see on the top here inside of the scopes panel. So this particular category simply it helps us to visualize the whites and blacks color tones inside of any image. So for example, here we have a blank canvas. If I navigate to the top, select to the pixels option, and inside of the pixels option, if I add in a new fill layer, which is similar to the solid color adjustment layer that you see inside of Photoshop, then by default inside of Affinity, this fill layer will have a pure white color filled inside of it. So one thing you might have noticed that is whenever we have or as soon as we have added the fill adjustment layer inside of our layers panel, it has added a white line at the top of this intensity waveform box, which indicates that our canvas is filled with everything white. So we can also control the color inside of the fill layer, and in order to control the color, navigate inside of the colors panel. After navigating inside of the colors panel, you'll see RGB selected by default. Change it to grayscale, and after changing it to grayscale, simply drop the value of the gray from white to black. And now you can see the color in our canvas is transitioning from white to black. And as soon as we do that, you'll be able to see that the white line has now shifted from the value of 100 to 0. So this indicates that the white line represents the brightness and the darkness tones inside of the image. To explain this much further, let us change our document to a new image, and inside of it, you can see that for this particular image, the intensity waveform category visualizes this image inside of the box in this particular way. That is, if you analyze this image closely, then most of the highlight tones or the bright tones are concentrated towards the top part of the image. And if you observe or analyze the box inside of the intensity waveform in scopes panel, then all of the intensity is being represented at the top portion of the box. What this means is any concentration of high intensity in any of the image will be represented at that particular position inside of the box. Similar to how, as you can see here, all the brightness or high intensity of the tones are at the top. So this indicates in the box that all of the values are at the top position right here. In simple words, this particular intensity is represented by the placement or the position of the intensity in the image. Experimenting this further, let us decrease down our brightness color tones at top of this image. So in order to do that, let's add a new curves adjustment layer. So we'll simply navigate below and select this icon. And after selecting this icon, let's select curves. And now you can see that a new curves adjustment layer has been added. We'll simply add a new point right here in order to make these color tones neutral inside of the image. We'll again add a new point right here in order to add the tones that represents this particular point inside of our image neutral, and we'll only control the one that is representing the tones at the top. So if we simply click on this particular point, which represents the brightness tones at the top of our image, and simply drag it, you can see that the bright tones are shifting or decreasing in our image. And if you look at the box, now you can see that all of the bright tones in our image has been shifted from top to the center of the image, which is being represented by this particular intensity waveform, indicating that the overall brightness tones inside the image has decreased in the top portion of our image. So I'll simply close the curves box right here. And now let's move on to our next document, which is the image 2 document right here. In this image, you can see that the most bright areas are at the top in the portion of sunlight, and the next bright concentration are in this particular area of the image. So in the visual representation of the intensity waveform, this particular brightness portion is represented by this particular waveform at the top, and this particular brightness portion at the center of the image is represented by this particular portion right here at the middle of the line indicated by the number 80. So similar to before, let's add a new curves adjustment layer here as well. So we'll simply add a new curves adjustment layer, and similar to before, let's add a point at the middle in order to keep the colors or values of the tones representing that point in the image neutral. And similarly, let's add next point right here as well to make the tones that represents this point in the image neutral. Now let's simply click this point and decrease it down like so, which will again decrease this particular brightness down in the image. And as you can see here on our waveform in the intensity waveform box, that the waveform which was representing this area is now decreasing towards the line of 80, whereas the brightness tones that were representing this particular portion of brightness in the image is only has slightly shifted below. Now let's close the curves box and let's hide the visibility of the curves adjustment layer inside of the layers panel. And as soon as we have make the visibility of the curves adjustment layer to off, you'll be able to see that now the brightness waveform has returned back to its normal position. Now let's look into our next category of waveform, which is RGB waveform. So in this RGB waveform, you can see that inside of this box, all of the waves are being represented in the R, G, and B color value formats, and it is associated with each R, G, and B color channels inside of this image that you can see on the left. To demonstrate, let's navigate below and select the icon of the layers panel in here and select the HSL adjustment layer. And after selecting the HSL adjustment layer, you can see that the HSL shift adjustment layer has been added. Inside of the HSL box, first of all, let's select all the colors or pick every colors inside of the image. And then if we decrease the saturation shift slider all the way down, now you will see that all the colors inside of the image will be desaturated. And if you look inside of the RGB waveform box, you'll now be able to see that all of the colors has come together and merged or overlapped with itself in this particular waveform view by giving us an intensity view of this overall image or intensity waveform view of the overall image. So likewise, if we increase the saturation shift again, now you'll be able to see that it has again segregated, or the waveform inside of the RGB waveform view in the scope panel has again segregated and provided us with the RGB channel color tones inside of the RGB waveform box like so. So one of the thing to understand inside of this RGB waveform box is that the white intensity waveform is a result of the mix of R, G, and B, which is the red, green, and blue color channels inside of this waveform box. So now let's close the HSL box, and after closing the HSL box, let's toggle the visibility of the HSL shift adjustment layer off. Next, if we open the histogram panel, you can see that The difference between the RGB waveform inside of the scope panel and the histogram waveform is that the histogram gives us the visibility of the tones inside of our image in a horizontal distribution view. However, the waveform will give us the overall tones of an image in connection to overall color tones of the image in an overall spreading view, or in both horizontal and vertical waveform view. Now let's move on to our next category of waveform, which is the RGB parade. So as the name implies, it will give us the visibility of each of the channels by segregating it in different columns. That is, if you look here, then the red is at the front, the green is at the middle, and the blue is at the end. And this particular category of RGB parade could be used whenever we are working on any color grading projects in an image. Right now, you can see that inside of the RGB parade view, each of the color channels, which is red, green, and blue, are at its peak towards the line of 100. However, by using the RGB parade category, we can adjust individual color channels and analyze the changes inside of the RGB parade waveform view inside of the scope panel. So for example, if we want to change the color green, all we can do is navigate below and click on this particular adjustment icon inside of the layers panel. And after that, let's select a new curves adjustment layer again. Now you can see that a new curves box has been opened. And from this new curves box, let's select the green channel. After selecting the green channel, let's now select the top right point of the green channel and then decrease the green, or we can simply click and add a new node or point at the middle and decrease the overall green channel inside of the image like so. And as soon as we do that, you'll be able to see that there is a slight change inside of the RGB parade waveform view, where the overall green are slowly starting to shift downward by making our overall image much more red or magenta. Now we can also simply click on the top right point and decrease it like so in order to decrease the overall greens that were present inside of the image. And now you can see that it is indicated in the RGB parade waveform view that the overall green that were available in this particular image are now slowly decreasing in numbers, in contrast to the red and blue channels. So we can also do the similar to the red and blue color channels as well. However, I'll close the curves box and then hide the curves adjustment layer like so, in order to get our image back to its original color and brightness tones. Now let's move to our next image document. And in this document, you can see that we have the image of a peacock feather. For this image, we'll change our waveform view to power spectral density view, which indicates or represents all the sharp edges or sharpness as well as the noise that are present in this image. If you look into the power spectral density waveform, every waveform data is being spread overall throughout the box, indicating that this particular feather has sharp edges as well as noise inside of it. And different colors variation inside of the spectral box also indicates that there are the presence of color noise inside of this particular feather image. Now the simple concept to understand here is the more spread there is present inside of the spectral density view, the more it indicates that this particular image has more sharpness as well as color noise. So to demonstrate this, if we navigate to the top and select the pixel menu item, and from the pixel menu item, if we select the live filter layer, and then inside of it, if we select the blur option and then add a Gaussian blur effect for this image, and then increase the Gaussian blur for this image by increasing the radius value, you'll now be able to see that the overall image is slowly blurring out. And if you look at the power of spectral density waveform view, you'll now see that every spread are slowly starting to concentrate at the origin of the waveform view of the power spectral density view inside of the scopes panel. which indicates that our image does not have sharp effects inside of it anymore. So similarly, if we again decrease the radius and bring those sharp effects back in our image, you'll now see that the concentrated density are now starting to spread throughout the power spectral density box right here inside of the scopes panel. So the bottom line is the power spectral density represents the sharpness as well as the noise inside of an image. Now I'll close the live Gaussian blur box here and then move to our next document. So inside of this document, we'll again change our category of scope from intensity waveform view to power spectral density view, where now you can see that different colors in this image are being represented by different noise inside of the power spectral density box. That is, it is also representing the color noise that are available inside of the image. So in order to decrease or get rid of the color noise inside of this image, if we go to the pixel menu item, navigate below and select new live filter layer, and from the new live filter layer, if we select noise option and select denoise and then decrease the color noise that were present inside of this particular image, you'll begin to see that the color noise waveform inside of the power spectral density box in the scopes panel has slightly shifted. So this was the before where there was more noise, and this is the after when we have gotten rid of most of the noises inside of this image. So we can also analyze this power spectral density box inside of the scopes panel to monitor and adjust the noise that are present inside of the image, apart from the sharp effect in the image. Now I'll close down the live denoise box, and similarly, let's move to our final image where we have the image of a subject. So in this image right now, we have an image of the subject, and if we change our waveform from intensity waveform to Vectorscope waveform, now we can adjust different color tones inside of this image. So if you analyze the Vectorscope category inside of the scopes panel, then we have different attributes in this particular pie chart view, starting from red, magenta, blue, cyan, green, and yellow. And the eye line here indicates the skin color tones, and the white concentration at the origin of this circle represents that much of the color tones and the brightness inside of this image are concentrated towards the origin of this pie chart. And to demonstrate the eye line, now let's select a crop tool, and then first of all crop towards the skin tones or the skin areas of our subject like so, and we'll simply crop it, only demonstrating or showing the portion of the image that has the skin tones available. After setting up the area of the skin tones, let's navigate to the top left corner and click on apply, and now you can see that we only have the skin tone sample from the subject. Now I'll be using the shortcut key of Command 0 in order to fit our cropped areas inside of our Affinity window. And if you look inside of the Vectorscope pie chart, you'll see that this particular skin tones is being represented with the white in the eye line inside of this Vectorscope representation. So right now, this white tiny blob is positioned near the origin of the circle, and the distance of the eye line represents that how saturated a particular color tones or skin tones is in this particular example. So to demonstrate, if I add a new SSL adjustment layer, and after adding a new adjustment layer, if we increase the saturation shift all the way to the right, you will see that the saturation of the skin tones has shifted, making it much more saturated. And if we observed the white tiny blob that was there inside of the Vectorscope box, then now it also had shifted from near origin to the outwards of this pie chart. So this indicates that the more the tiny white blob moves towards the edge, the more saturated the color tones are inside of the image, and the more it moves towards or near the center, the more less saturated the color tones are inside of the image. So if we drag the slider of the saturation shift to the left, now you will see slightly that the white tiny blob is starting to move or position itself towards the center or origin if I decrease the saturation shift slider all the way to the left like so. And it has converged towards the origin of the pie chart inside of the scopes panel. So I'll set the slider value towards 0% for now in order to make it to the default value. And now I'll close the HSL box like so. So basically, we can monitor and analyze the overall color tones inside of an image by using the Vectorscope box inside of the scopes panel in Affinity. So the main thing here is understanding the scope panel will give us more advantage in order to tweak different color tones and brightness values inside of image to make it look much more professional inside of our Affinity app. So if you have understood the concept of the scope panel inside of Affinity, please give a thumbs up, and for more tips and tricks related to Affinity, hit the subscribe button. Thank you for watching this video and see you on the next video.